What guidance does Cisco give us on the data center architecture that they would recommend? What exam questions might we expect on this topic? Let's answer those questions and more in this nugget. We really want to focus this nugget into three areas, by the way. We want to talk about why it is that we see local area networks and storage area networks segregated. I mean, why wasn't it always the desire of organizations to take this traffic and mesh it together? We'll see why in this nugget. We'll also talk about the three-layered architecture that Cisco likes to recommend for network infrastructures, and we'll talk about a variation of it called the collapsed core. And then finally, we'll wrap up just by giving you some overview information of the most important categories of what Cisco calls this new evolution of their data center networking. They call it 3.0. I know I've taught it to you in other courses, but in this particular course, let's make sure that we understand the major tenets of data center 3.0. So why is it that we so often see the local area network completely segregated from the storage area network? There's a real attempt to keep the local area network traffic and the storage area network traffic separate. Well, one of the important reasons has always been security. The idea is that hacking methodologies that would work in the local area network, if we segregate the storage stuff off of that LAN, those same hacking methodologies would not work. Another real big reason was always bandwidth. The local area network was perceived to be a much lower bandwidth infrastructure than the storage area network. So we'd take our data, put it in the SAN, and give it really, really high bandwidth amounts. Now we know today the local area network is certainly catching up with the bandwidth capabilities of the SAN, and that's definitely a consideration. Another major factor for the segregation has always been flow control. Let me elaborate on flow control next in this particular nugget, but just suffice it to say that in TCP/IP based LAN environments, there can be a lot of bottlenecks, and these bottlenecks can lead to dropped packets. Dropped packets is something that is not tolerated in the storage area networking environment. And finally, overall performance. It was deemed that the storage area network segregated information would achieve higher performance levels than that of the local area network. Now, something else to keep in mind, as I alluded to, is storage area networks just don't really appreciate the way in which LANs do their flow control. Remember what happens. In a LAN environment, a transmitter will transmit packets, be firing packets off at the receiver. If the receiver gets congested, it will drop some packets and it will try and signal to the transmitter later in this course. Now keep in mind, when Cisco is designing these modern data center infrastructures, they will still use a layered and modular approach. This really helps the scalability of the design, right? It is very easy to go ahead and scale it out, and it's also very resilient. So this is a reliable, resilient type of design. The layered approach says that we're going to have particular equipment that we consider the data center access layer. As you can see here in my depiction, this might be C-series rack-mounted servers. These might be those B-series blade servers in a UCS chassis. We then have what's called an aggregation layer, and then finally there is a high-speed core layer. So if you're familiar with other design classes, maybe even the CCDA training that we deliver here at CBT Nuggets, if you're familiar with this three-layer concept of core, aggregation, and access, you're going to feel really comfortable with the modular approach that's used in the data center because these three layers exist here as well. Now, what you can run into in the storage area network a lot of times is a small number of switches that have just a single layer. And these single layer of switches will make redundant connections out to the servers that are actually providing your storage. Notice this is a pretty inexpensive and easy way to manage your environment because you have a few number of switches to handle that have redundant connections out to the storage devices themselves. But as you might guess, this is not the only particular architecture that is utilized. A lot of organizations will indeed start to scale this out by adding additional layers of storage switches. And we'll be talking about these types of designs and even how they are implemented in the course. One of the things that we're going to have, obviously, here is larger numbers of inter-switch link connections in this particular storage area networking environment. Now, let us talk about these particular modular designs in more detail. For example, when we talk about the core layer of, let's say, a LAN data center infrastructure, what technologies are we really discussing in that core layer? The core layer of the layered modular approach in a Cisco environment makes sure that we have large amounts of bandwidth. 10 gigabit per second is the standard in the core, and we even see 40 and 100 gigabit per second pipes in this high bandwidth environment. Administrative domains and policies are sketched out so that we could have separate cores in our infrastructure that help really define the administrative boundaries of our environment. And also, the core can really help us implement new high-speed data center technologies that may result from future developments in our organization. Now, while these layers are awesome and each can have their own particular functions as we've sketched out for you, I need you to be perfectly clear on something. Many organizations today, both in their LAN and their SAN designs, they are doing what we call a collapsed core. What does this mean? It means the aggregation layer is moved up into the core. So whenever you hear collapse core, I want you to realize we are talking about a design that has core layer devices and then it has access layer devices. So we really just define a core and an access. This can be done with layer 3 throughout. This can be done with a mix of layer 3 and layer 2. Layer 3 traditionally being done in the core and layer 2 being done out at the access layer. So please keep in mind that in both local area network designs and in storage area network designs, we can go with a collapse core approach. The minute you hear collapse core, I want you thinking of just that two-layer core and access design. Now, as promised, let's talk about Cisco's Data Center 3.0 initiative a little bit. This is a nice preview of what we're going to be dealing with in depth in this course. When it comes to the 3.0 data center, Cisco really emphasizes virtualization. When you say virtualization, it means different things to different people. For instance, if you have a VMware background, you would immediately think about virtualization in your server environment. You would think about perhaps a C-series rack-mounted server from Cisco that is actually running many different operating systems thanks to the VMware hypervisor. While certainly we're going to deal with that concept in this course, we don't just stop there. We're talking virtualization in the network environment, right? Something like the 1000V from Cisco Systems. And we talk about things like Cisco's VN link technology. We're going to talk about this a lot in this particular course. What this means is when we have one of these, let's say it's a C-series rack-mounted server, and it's got different VMs running on top of it, right? When each of these VMs is communicating through a single, let's say it's a 10 gigabit per second pipe, we want to be able to track the traffic of that individual VM as it is moving through our network infrastructure. This is what VN-Link is all about, to literally be able to tag and distinguish the traffic of one virtual machine from another virtual machine. So virtualization, yes, it's going to be very much present in our modern data center, and we'll be dealing with it throughout this CBT Nugget course. As I alluded to in this particular nugget, the fabric is unified. This is thanks to technologies like fiber channel over Ethernet. We'll talk about data center bridging in here. We'll talk about iSCSI technology in here. So all of these technologies are going to be defined and supported by Cisco in order to marry the traffic of the LAN and the storage area networking wherever we need to in our data center environment. And then we have unified computing that is available from Cisco. This is going to allow us to do a heavy, intense amount of virtualization, but it's also going to enable us to very reliably connect many different servers into the LAN and SAN infrastructure. So we're going to bring the intelligence and the information that's in the LAN and the SAN, and we're going to give it easy access to the server blades that are wanting to consume this information. If you have no experience with the unified computing system of Cisco Systems, then don't worry, you're in the right place. In this particular course, I'll walk you through this UCS system, and you can see why it is such an amazing product line from Cisco Systems. You're going to be able to deploy servers in your infrastructure completely ready and raring to go for particular functions. Maybe it's e-commerce, maybe it's database, maybe it's, I don't know, some financial analysis. You'll be able to deploy these servers and have them ready with just a few clicks of the mouse. So did we cover information in this particular nugget that is certification relevant? We sure did. So as such, let's do some sample review questions. These are the types of multiple choice that you could certainly see in your exam environment. Which two are not advantages of a modular data center design? We have to choose two here. Two of these are not necessarily advantages that we would get when we shoot for modularity in the data center. Resilience, ease of management, complexity, and scalability. Well, we said that when we do a modular data center design, it adds to the resiliency and scalability. So the two here that aren't really advantages would be ease of management and complexity. Look, we love ease of management, but when we do a modular design, it really doesn't lead itself to ease of management. In fact, if anything, it makes our lives as managers all the more complex. And complexity is another one. We don't increase, or the fact that we do increase the complexity of our design isn't a good thing, really, but adding to the complexity of our design helps give us the resilience and the scalability that we're looking for. So think carefully. Don't answer too quickly when it comes to these questions about design modularity and the three-layered architecture of core, aggregation, and access that we'll run into in the exam. Let's take a look at another one. What are two features we might find in a data center aggregation layer? Again, our job here is to choose two. Security QoS marking, various services, or high speed switching? Wow, what a tricky question. We certainly might find QoS at the analyzing the traffic that is coursing through the veins of our modern data center. Which two layers result in the collapsed core design? Do you remember this? When we collapse the core, we end up with the core layer and the access layer. Another way to solve this, by the way, is to realize that distribution and aggregation are a description of the same layer. Some people will call the aggregation layer actually the distribution layer. You'll often see it oftentimes too as the policy based control layer. And all of these are trying to describe that particular layer. If you have two of the options that are the same thing, it's probably not going to be right, right? So anyways, this was pretty easy. We know that when we collapse the core, obviously we get a core layer, and the only other layer that exists is that access layer. So, congratulations, you just survived your first nugget of content in this course. And we started out mild, didn't we? Sure, we took a look at the segregation of local area network and storage area network traffic. And you now really understand why traditionally that segregation has taken place. One of the big topics there we saw was flow control. And storage area networking is really intolerant of the approach that could lead to drop packets that we would find in the traditional Ethernet-based LAN. We talk about that layered architecture, that core, aggregation, and access approach that Cisco has always used and that moves right into the data center environment. And then we wrapped it up with a nice preview of topics that we'll see in the rest of this course. We talked about the three-pronged approach of Data Center 3.0. Do you remember it? It was a heavy dose of virtualization. It was our wonderful unified fabric, which is really exemplified by a technology called fiber channel over Ethernet. And then finally, it also consists of the unified computing system. Again, we have nuggets dedicated to those various topics coming up in this particular course. Well, I hope this has been informative for you, and I'd like to thank you for viewing.